and welcome back to my channel, or hello if you're a new viewer. Today I'd just like to look at commercial RS232 isolators from 4 kV and above. This is a port powered 4 kV RS232 serial isolator. We'll open it up, have a look inside as to how they provide the isolation. So we'll take the case apart. It just unclips. Now this could be port powered, or it has individual power points. I think it's reasonably complicated. Turn it over. The label gets in the way. If we zoom in, so there you can see the isolation gap. Not the best practice to stick a label across the top, because if that glue in any way is conductive, you are shortening your isolation gap. If it was made of paper and it got damp, and of course you are putting a conducting path across there, and this is designed to take 4 kV. If you bring a ruler in, it's close to 4.5 at its narrowest point, 7 at its widest. So that's the sort of gap you need to get 4.5 kV or 4 kV isolation. And part of the size of that gap is dictated by, obviously, the width of that IC. Let's just focus again. So that there is your IC providing the isolation. And so the maximum isolation you could ever get on this board is provided by, or determined by, the distance from where the pin enters a body here to where it leaves the body there. And so you've got a tracking distance across the chip and underneath the chip. So that's the best you'll ever achieve. And we'll throw up some data sheets and we'll look at what however you pronounce it, ADUM2402. I think it's just a digital isolator, and these are RS232 chips. And then we'll look down at these components around here as to what they actually do. I'm not going to go into great detail. Say this is a commercial product. We're just going to have a quick look at the idea behind it. So what are these little chips? Can we see? It's on the manual focus. Try and get the light to shine on it properly. 7660. So we'll have to look up and see what they are. We'll look at the data sheets in a minute, and there's a close-up of, not too close. Oh, there we go. ZT2343 LFEY. So I expect the chip on the other side is exactly the same. 2343, yep, same chip. And it's the same chip there. So they just duplicated what's on either side of the ADUM2402. So there you have it. Socket on one end. Let's pull this back up again. Socket on one end, plug on the other. So you should be able to just disconnect the RS232 line and put this in, and you get isolation. But you need to have full RS232 connections on this end with all the DTRs and RTCs and RTSs and DTRs and all that, because this will pull power from those extra control pins to power the circuit. If you've only got ground T.E.H RX, then you have to put power in from the side, and it takes anywhere between 5 to 12 volts. And then again, if you're going to put power on each side, you can't just put one power lead in and then bridge it over. You've got to have two separate power supplies with isolation between them. So, you know, maybe a battery on one side and your equipment power the other side, or some other form of isolation, because there's no point putting a 4 kV isolator on the RS232 line in here if you join the powers together, or you join the powers together with power supplies that have got ratings of less than 4 kV, because if obviously the voltage coming in will take the shortest path of, or the path of least resistance, and if it's going to get up to 4 kV to get across there but only like 1 kV to get across there, you've only got 1 kV of protection. So let's have a look at some of the data sheets. Well, here we are. There's the data sheet for the most important chip in the unit, the AD-UM2402. It can be run at 5 volts or 3 volts, and it's bidirectional communication. And if we look down to the packages, there are 4 channels in each device, and the family, or the last digit, just lets you know the actual configuration of the 4 channels. So like the 2400 is all in one direction, so that's all signals crossing the barrier, which means it's unidirectional. You cannot, you'd need 2 of these to make a bidirectional. Then you get to the 2401, you can see there that has 3 channels going in one direction and 1 return channel, and the one that's used in here, there are 2 channels going in each direction, so you've got 2 bidirectional channels crossing the isolation gap. And you can see these ones are transformer coupled, although they're indicating that they're transformer coupled. And if you want to use this in the real world for any kind of safety applications, these are the bits that are important. You know, the UL recognition, the CSA, the VDE, they're the bodies that you would look for the approvals. So that when you go down to here, as it gone, regulatory information. Now the simplest and the easiest ways to look at these things is if it's got a UL mark, you look for the E number, and you can go to the UL website and you can type in the E number and do a search for that E number, and you will get back all the information that the company submitted with all the test results done by UL to concern that product or that family of products. So that file will cover probably several classes of chip, and so let you get down here, the actual chip itself can withstand 5,000 volts, and they give you the minimum air gaps, creepage. So creepage is where it gets from one terminal to the other. So the creepage distance on the chip would be from out of one pin down the side of the body, or up along this body, along either the top or the bottom, and then down or up the other side to get to the pin the other side. So from one pin to the other, that would be the shortest distance. And so that's the air gap would give you the best PCB isolation, but you're never going to get better than the creepage of the chip itself. So I hope that helps. And so in the data sheet there are all different safety cases that are described. So they've obviously decided that the chip can withstand 5,000 volts, but when they've put it onto the PCB, that's going to reduce it. So they've rated it to 4,000 volts. So that's the actual chip doing the isolation. We'll have a quick look at the chip doing the RS232 conversion. All right, we're just going to do a quick look at the ZT2343 datasheet. Just have a quick overview of what it does. And as you can see, it's a 3 volt powered EIA/TIA 232 and V28 V24 communication interface with low power requirements, and it has a proprietary switched capacitor regulated voltage converter, which basically means you only have to give it one voltage of say 3 volts to 5 volts, and it will generate plus or minus like 12 volts required for RS232 to be compliant. We're not going to go into depth. We'll just go down to right. This is the sort of like functional diagram of the chip. Supply decoupling, always important. The internal oscillator frequency, I expect, is controlled by these two capacitors, and these two capacitors provide the output filtering of the internal step-up signal oscillators in here, stepping up to say plus 12, and that's stepping down to minus 12. There we have 4 channels TTL to RS232 outputs, and then down here we have 5 RS232 level inputs to 6 TTL CMOS outputs. So that's changing, 0 to 5 volts, 0 to 3 volts levels to sort of like plus or minus 12. Basically, our non-isolated RS232 comes in onto here. This converts it down to the TTL levels. That then passes into the isolation chip, which passes those TTL levels across the isolation barrier back into the second one of these, where it comes in as TTL and it goes out as fully fledged RS232 levels, and that's all it's doing. Right, and we move on, staying with the theme of RS232 isolation. This and another one, and the length of fiber coming out of here, and you can have any isolation you want, from a few kV up to hundreds of kV, because depending on how long you leave that fiber cable, that's one heck of a distance to jump. We'll just pop it open. Fiber optic transceiver module, transmit out, receive in using standard ST fiber, and just roll it over. The main chip we have here, which if I bring up, ZT3243, the same chip as used on the other board, giving us the 4K. That's RS232 taken to the limits, about 2 kilometers. So great isolation, and even better is the fact that you can go quite a distance and you will not pick up any interference, as fiber transmits light, and light isn't affected by electric or magnetic fields, so no noise at all. So very good solution for longer distances. So if your workroom is in the shed at the end of the garden and you want 232 connections down there, this will do it no problem whatsoever, and you shouldn't get any corruption due to noise or voltage differences between grounds. So I've got one more to show you, which is good if you want faster speeds. And if you want to go one better than RS232 and you want gigabit speeds, then you can use something like this, which is a Ethernet switch or hub. That's a switch. Ethernet cables going in, a fiber cable coming out. And with these you can select different modules that plug in here for different fiber types. So it's quite convenient. You can change it, and it's also a little, it's got a port on it as well. So if you wanted to have a LAN connection at the end of your garden and you didn't want to use Wi-Fi, this will give you a good secure LAN, because obviously no one get at that fiber, and of course it doesn't radiate, it doesn't pick up. So you get gigabit speeds, internet connection, and fantastic isolation. So that's the kind of the top end. Thanks for watching. If you liked it, hit the subscribe button, click on that notification bell, and I'll see you on the next one.